Hello everyone. So I just wanted to give a little spill of what we do in the pathology world, the histology pathology world, and what the histotechs do as well in order to, from when the surgeons or doctors get a biopsy and they send it to us, and how we make it into a slide like this. How I look at this under the microscope to make a diagnosis of cancer or not cancer. If it's not cancer, what kind of disease process is it? Or if it is cancer, what kind of cancer it is? And that's what we send back to the PCM or surgeon or whoever, an oncologist. Anyways, the first step is we get specimens from the OR or from clinics, the different clinics, and each of these containers has a fixative solution in it called formalin. Okay, yeah, that was my partner. He's the other pathologist. So anyways, each of these, the doctors put in the biopsy sample and then they fill it with formalin. If it's a gynecologic tissue, sometimes they'll use, it's a fixative solution. The most common fixative solution is 10% buffered formalin. And so that's what each of these containers have. And what that does is it just helps fix the tissue and the cells so they don't break down, so they don't get necrotic or die. Anyways, then what we do is they accession it into the computer, so it's in our system, and then we bring this container over to our grossing table. And here in the grossing table, we got to wear our PPEs, the protective equipment, goggles, gown, and whatnot. And then what we do with those containers is we open them up. If it's a big specimen, we take it out, we look at it, we look to where anything looks diseased or different, we cut into it, and then we get I know it's kind of hard without an actual specimen, and then we get little pieces of the tissue and we put it into a cassette. And the cassette here is just this little 2 by 1.5 inch container, and we snap it shut. So the tissue has to fit within there and be ideally less than a nickel thickness. Once we put it in there, we label it with the patient and the accession number. And what we do with these, we put it in a tray with all the other cassettes of tissue that we've grossed in, and then we bring it over here to the tissue processor. And the tissue processor goes through anywhere from like a 4-hour to a 10-hour cycle of where it switches, goes in between different types of solutions, formalin, alcohol, and so forth. So go ahead and zoom in on these. So these are the different stages it goes through to help fix the tissue so that we can cut into it. So NBF is non-buffered formalin, alcohol, and clearing solution. Anyways, I guess I better not open that. So that's what we do. So it goes through this processor overnight, all these tissue cassettes. Then we, in the morning, the techs come take them out and they bring it over to this embedder. And what they do is they sit here. This is this is heated. This little platform here. And what they do is they get the tissue and they put it in, wax comes out of here, kind of liquid wax. And what it does is it pours in and forms kind of a pool. The tissue will be inside that little pool of liquid wax. Then as they transfer it over here, it cools down and the wax hardens into what we call a tissue block. And so the tissue is inside that wax, that solidified wax, if you will. then what happens is then they get this wax or this the tissue block, and they come over here to the micrometer here, and this thing, this isn't exactly what they put in there, but so this is what the tissue block would look like. So there's a piece of tissue in there, the tissue that we cut up, and the block, and this is really flat. So what they do is they insert the tissue block in there, and the blade here slices it, so it creates little wafers, little slices, and the thickness of that is anywhere from 2 to 4 microns in thickness. Just to give you an idea, a red blood cell ranges from 7 to 9 microns in thickness, whereas this cuts between 2 and 4 microns. So it gets every cellular detail. It'll cut through all the cells, and so that way we can see it under the microscope. Anyways, once that wafer comes off right here, then what they'll do is they'll get a blank slide, or actually they get that little wafer, if you will, they put it in a water bath and it floats on the water bath. Then they get an empty slide, and they just bring it up into the tissue wafer. The wax dissolves and the tissue adheres or sticks to the slide. Now, we're not quite finished at that point, because right now we do have a tissue on the slide, but it's just clear. You wouldn't be able to see anything under the microscope. So what we need to do in order to see all the different cellular structures is stain it up. And how we stain it up is then we bring it over here to the fancy name of a stainer. And so this stainer, the two primary components are the hematoxylin and the eucin. And how they stain the tissue is depending on the charge of the cellular structure. So in general, the nucleus has a negative charge and the cytoplasm has a positive charge. And what happens is the hematoxylin is more of a positive charge stain, and so that hematoxylin will stain to the negative nucleus, so it will become more blue and darker. And then the eucin is kind of a pink stain. The hematoxylin is like a bluish purple stain, and the eucin is a pink, more of a pink red stain. And that has a negative charge, the solution itself, and so that will adhere to the positively charged cytoplasm. So then in general, the nucleus is a little darker than the rest of the cytoplasm, and also the surrounding tissue, what we call like the stromal tissue or the connective tissue that holds the cell in place. So it'll go through this over a certain time period, maybe an hour, maybe a little less, half an hour to an hour, and then it'll plop out here, and then this automated machine has a cover slipper. It'll stick a cover slipper over this with I guess some kind of gel glue or whatever, and it will make it stick. And so then the final product, and then our techs label it. Then our final product is the tissue that is stained up. Here it's mostly pink, which is a good thing, and then the cover slip, and it's on the slide. And that's how we create these slides. So, and the next clip will be what it looks like under the microscope. Hello again. So here I am in my office, and what I do now is I get a tray full of these slides. I'll put it on the microscope stage, and at this point, in order to show you guys what this entails, here we go. Let's see if this works. All right. So this is a skin biopsy. I'm trying to zoom in. This is harder than I thought it was going to be. So yeah. So this is the blue is the nuclei of the cells. Sorry. Trying to move the stage with one hand and guide the camera with the other. Okay, it's probably about as best as I can get it. So this is a benign nevus, and that's how we make this diagnosis. We look at it, and from our training we can recognize patterns and cell types and what we're looking for. So anyways, I know that was kind of a little amateurish explanation of what I do as a pathologist, but I hope you enjoyed this little tutorial, and we'll talk with you later. Thanks.